Welcome. Thank you all for joining this webinar today. So we will present two reports prepared by our working group standardization. So high-level architecture report release 6 and guidance for the integration of digital twins in data spaces release 1. Let's go to the next slide. Let's present the agenda for today. Next one. So after very quick opening and welcome, we will have the presentation of the first report given by Georgios Karagiannis, who is the working group co-chair and paper editor. And then we will continue with the presentation of the second report, which will be done by Antonio Kung, who is our working group standardization chair and also paper editor. And then we will continue with the questions from audience. You can either raise your hand and ask question, or you can put it in chat. And then we will try to reply, and then we will have a quick wrap up of the webinar. So let's go to the next one. Just to give you a bit of an overview about our standardization group, because of course we know there is a lot of members of our community there, but also external participants. So just that you have a bit of idea what this group is trying to doing and how we are coming to the reports. So you see that we have, of course, chair and co-chair of the group, so Antonio and Georgios will be also presenters today. And you can see that basically we have almost 100 member organizations participating in group and its various task forces and focus groups, and almost 200 participants. And then you can see from the deliverables what are the topics covered by the group. So IoT and edge computing landscape, high priority gaps, IoT relation and impact on 5G and beyond, high-level architecture. So two reports today will be from that area. Ontology, meaning semantic interoperability, and then computing continuum. You can also see that the group has quite developed liaisons and work with the sorry, I just need to mute other colleagues. Sorry for this. So basically, you can see that we have quite developed also collaborations with other standards development organizations and alliances, because we want to develop basically co-creation and work with them, either through memorandum of understandings or through liaisons, including but not limited to ISO IEC, AIOTI, IEEE, and others. You see that we also have collaboration with 16G, with other European EU-funded projects like STAND ICT, but also HS Booster. And then we are also members of the high-level forum on European standardization and ICT multi-stakeholder platform, which also provides us with platforms to provide input related to standardization in various domains, not just ICT. And then, of course, the group contributes quite, I would say, strongly to a lot of events that either we organize, like today, this webinar, or our annual events, like we had signature event last year, AIOTI Days this year, a couple of weeks ago, and then also to other external events. Let's go to the next one. So now we can start actually with the presentation of the first report, and I give floor to Georgios to present the report on high-level architecture. So thank you. Georgios, please.
Thank you, Damir, and welcome, colleagues. Welcome everyone to this call, to this webinar. And what I would like to present now, as already Damir mentioned, are some insights coming from this report that we have published this year on the 22nd July. And it's about high-level architecture report, release 6.0. So we have several releases that we have published before, but we have done some additions and changes, and you see them. You see, a list with these additions in the next slide. But before going there, so let's provide some information about the goal of the report. So in particular, what this report is about talking and discussing a functional reference architecture that could be used in I heard an echo. That could be used in IoT and edge computing, area, and is based on the ISO/IEC IEEE 42010 specification, and it actually includes several features and capabilities that you see there list. So edge computing, computing continuum, AI, data spaces, and I will go into that in a while, as well big data, virtualization, security, privacy, and platform interoperability. So the main concept that we have actually developed since the beginning, since release 1, in this high-level architecture, you see it here and on the bottom of the slide. So the HLA includes 3 key layers. So we have the application layer that provides communication and interfaces to processes, and then we have in the middle we have the IoT layer. We'll also call it the data layer. I mean, if we talk about data spaces, and it's actually grouping IoT functionalities like data storage, data discovery, data sharing, and it provides APIs towards the application layers. I mean, the application layer is the top layer, and the bottom layer actually is the network layer. So the IoT layer makes use of the network layer. So the services like data services that provide communication between short and long-term type of communication, provide data forwarding between entities, and as well control functionalities that are related, for example, to QoS, localization, and others. We go to the next one. Next, yeah. So as I mentioned, we have done some updates. So there were updates, but also additions, so added sections to that. And the sections that are marked here with yellow are either new ones or updated ones. So what I would like to focus today are on 2 key updates or key additions. So the section 6.8 that is focusing on data spaces, on how data spaces, but as well digital twins and AI could be represented using the AIOTI HLA, the high-level architecture, and then also section 9, and that is an updated section that's focusing more on how you actually use artificial intelligence in the IoT domain. Next slide, please. So then let's go to the section 6.8 that I was mentioning. So this focuses on one subsection, 6.8.2, and is showing actually how the figure on the left, it shows how you could represent data spaces. So it's a data space representation, and it actually is composed by organization, as you see there. And that organization are actually, it could be domains, or it could be any kind of entity that needs to use, to exchange data. And there are 2 layers in this data space representation: the processing layer and the data layer. And there are 3 key concepts used. So we have a data exchange that exchanges data between different organizations, and we have this data interoperability that's actually including also the communication between these entities. I mean, what are the data forwarding that I mentioned before, that kind of services, controlling data services, and as well it supports interoperability. So that's what the data interoperability does. And then we have the third concept is data operation that provides communication between these processing entities that I was talking about, with entities that could be used in data storage and data computation and things like that. So, and then the right part, it shows how the HLA could also be used. The AIOTI HLA could be used to represent this data space representation that you see on the left. So what I mentioned is on the right side of the figure of the slide. So you have the application layer that could represent the processing layer used in the data space, so data space processing layer. The AIOTA data layer or IoT layers I mentioned can represent the data space data layer, and then it's also be able to represent the concept, the data exchange concept. And then an ERCO layer, as I said, it supports the data forwarding and data kind of data services. So it could actually, it can represent the data interoperability concept. So these are the mapping between the data space configuration in IoT HLA type of configuration, and these two types of representations are also used in the subsequent slides. So we go to the next slide, Damir. So this slide is about is actually section 6.33 in the report, and it talks about digital twin, but also how you could use the AI capability in digital twin, and then how you could represent them in the left side using the data space configuration, data space representation, and on the right part is the representation using the high-level architecture. So in the left part, as you see, you have the organization, the data space organization that I mentioned previously. R2 in this case is the digital twin virtual entity, so one data space organization, and the other data space organization is the digital twin physical entity. So you have two data space organizations that need to communicate and exchange data between them. So then you have these concepts that talking about on data interoperability, data exchange that need to happen between these data organizations, and as well the data operation that takes place between these two features that are AI-related features, handling and reasoning, that is part of the processing, data space processing layer, and the data and knowledge that is part of the data layer. And then you have the right part in this slide shows actually the HLA representation. As I said before, the application layer, the HLA, the IoTA application, HLA application layer is representing the processing layer, data space processing layer. So you have the handling and the reasoning type of processes. And then the data layer, the HLA data layer, is representing the data knowledge that I showed previously in the left part. And then you have these data operations that are interfaces, APIs between these two types of function, the process that is handling the reasoning, and then the data and exchange on the data layer, and then again the network layer supporting the data interoperability. So as I said, communication between all the entities, and as well support of the interoperability for that. So if you go to the next slide. Yeah, so then another section that is important is section 6.8.4. So it talks about the computing continuum, concept, and how this could be represented using HLA. So again, on the left part, we use the data space configuration to show, this computing continuum concept, and then we have in this computing continuum concept, we have three organizations in the data space concept, the IoT, edge, and cloud. So going from left to right. And then between all of this, you have to have a data exchange, data interoperability, and then also data operation between the different processes and data related entities. And then the same type of mapping that was done previously, for the digital twin is also seen here, where you have again the application layer supporting the processing layer, the data space processing layer, the HLA data layer supporting the data space data layer, and again, the data exchange that could be supported by the HLA data layer, the data interoperability supported by HLA network layer, and you have this data operation that takes place, between the entities, processing entities, and the application layer, and the ones in the data layer. And you have again these three data space organizations: the IoT, Edge, and Cloud, and you have to have a strict communication between them when you want to realize the company continuum concept. Next slide, please. And then we have also another section, 6.8.5, that is talking about federated system perspective using the HLA representation. And again, on the left part, you see well, it's actually what it shows now is the HLA, how HLA can represent federated systems. And as what you've seen previously in the previous slide, we're talking about one domain area. But now, using this type of federation, this type of mapping and representation using HLA in this case could also be used between different domain areas. So you could have, say, a cloud computing continuum domain in one domain, like what you see on the right figure for the energy data space ecosystem. So you could have a computing continuum, so a vision or perspective or system used in the energy data space, and you could have another computing continuum system in another domain area, like the transport data space ecosystem. So then, if you have these two type of ecosystems, you also have to have ways on how you could have a federated data exchange, as you see on the right part, and federated, and then also federated data interoperability, and as well as data operation, but that is within one domain. So in this case, you could also, so as mentioned here, you can apply the HLA representation not only in one domain area, but also in more domain areas that are federated with each other. Next slide, please. And then the last subsection that we have in the report is talking about the data collecting and trading perspective using HLA. So in the case of data markets, data marketplaces, and you see that the data space organizations are represented by the data collection. So it is one organization that needs to exchange data. Then we have the data trading, and those are also have include the data provider, marketplace, and data consumer. So all these three would be seen as different data organizations, and all of them need to communicate with each other, exchange data, and of course they also need to support interoperability, communication, interoperability between their entities, and all this could be and more details are explained in the report, and actually, the first version of this kind of mapping was also done also by AIOTI in one other report that we had, that we were talking about how you could actually integrate data spaces into IoT, and there some more information is also provided there. But this information is specifically now focusing on how HLA could be used to represent all these concepts. Yeah, the next slide, please. Okay, and then the other section that I said that I will go through and I'll provide some insights is about artificial intelligence for IoT. So how I could use and make useful artificial intelligence in the context of IoT. So and here's some concepts. I mean, if you have one of the things that are important is data information and knowledge. So we're talking about both about artificial intelligence and IoT. So data is, if you collect data, the data is raw. Provides raw facts and figures. So if you want to have some more information, you need to have some knowledge. So knowledge is a step further that combines this information that you collect, but it uses also metadata, such as data handling policies, or sometimes ontologies, but also other kind of constraints that need to be applied. And then from this data, you could get some more knowledge, some more useful information. Then the next step is the reasoning. So it's actually the process of drawing conclusions, drawing inferences from new and existing information. And there are different ways on how this is used in AI. For example, logical reasoning, rational plausible reasoning, inductive reasoning, but I'll not go through them. You can look into the details later. But so this is a very important step, because if you have this information, so you collect data, you have some knowledge from using this metadata, but at the end you need to have some kind of conclusions in order to get the useful insights from what you collect. Next slide, please. And then another information that we have in that section is about the role of AI in enhancing IoT capabilities. So, and it's explained how AI could actually be used to enhance those IoT capabilities. And for example, how to analyze, it's important, that the AI technologies and also the deep learning, the machine learning, could provide means to be able to analyze the very big amounts, that you collect via the IoT devices. And by doing that, you could enable more efficient and more intelligent decision making, and have some kind of automating complex tasks. And then, of course, as I said previously, to also improve the efficiency and effectiveness of IT solutions when you use AI. And another, subsection that we are focusing in the report is the role of AI for control of IoT. So, you could use AI to for example, provide some control on dynamic orchestration and optimize the utilization of resources when we use this concept of complete continuum, as I said, because that's a quite complex system when you use IoT with this vast amount of large amount of devices. And then the other thing is machine learning, that could also be used to train real-time models. Can someone mute? Hello. Including recognize and acting upon events. So machine learning could be used also to make the operation of IoT and control IoT in a very very efficient way. The next slide, please. And then the other part, and that's an important one, a subsection that we're also providing there in the report, is about the importance that frameworks and standards have for AI in IoT. So if you want to use AI in IoT, it is very important to have some robust framework and use international standards, particular, to ensure interoperability, security, and privacy. And there are different arguments that we are providing there. So, but one of the most important one is, of course, to be able to have frameworks to to enable and facilitate a seamless data exchange between this large and diverse amount of IoT devices and also platforms, and then at the same time to provide a secure environment for artificial intelligence algorithms that could operate. So that's a very important argument that we're running there, and so more details could be seen in the report. Next slide, please. So then going to the highlights and recommendations. So the HLA, as I said, this is release 6. So we started working with this some time ago. And the main goal of this HLA was to be used in large-scale pilots. They were done, I think, in the 2016, 2017, in that time period. But the HLA is used and could also be used in different European, also current, but also in future European funded projects. So the current version of the HLA report provides insight on how frameworks and also concepts such as data spaces, AI, digital twin, as I provided some slides, previous slides, and so integrates all these concepts into the HLA. So HLA is done in a way that could represent different types of capabilities and features. And HLA is also considering, the architecture specifications that have been done in other SDOs and also in SDOs and other alliances. And we have done, for example, if you look into the report, you'll see that there is a mapping done between the reference architecture that were developed in different SDOs like 192M, AIOTI, and then also the associations, the industry associations like Industry 4.0, BDVA. So all those are mapped into the HLA, and well, we use also HLA as bus for discussion with different groups. In particular, AC41 were in ISO ICGTC1, but Israel in AIOTI G20. So, and then as you see in the last bullet, so we need to actually continuously, monitor and find out if we need to update the HLA each time that new capabilities are there and need to be, if you want to represent them, of course, with HLA, we need to update the HLA. So that's important thing that we did for release 6. Going to the next, can you hear me well? Okay. So if you go to the next slide, please. So then going to the next steps and discussion. So as I mentioned, we have published the report in July of this year, and we are started working with the release 7. But we need, of course, to connect in order to have an useful update. We need to have some more input from UI and ITM members to be able to include this kind of new developments, like that could be applied for in the IoT area. So such kind of developments, you see some examples that are virtual worlds, immersive technologies, and then the new concepts that were already explained, but maybe there will be some more, additions to the data spaces work, AI and digital twin. And then, so questions for you, for the audience. So first of all, we have, 2 key questions here. Is this report useful for your community? So if you can, please answer now, but otherwise you can let us know offline, and then we can have one-to-one discussions for that. And then the other one, are there any up-to-date IoT developments, in addition to what we provided in this report, like in virtual worlds, immersive technologies, and also new concepts in data spaces, that are known to your community that might impact HLA, and that it's useful to work out and see how we can include them in an update of the HLA report. So again, if you have any kind of insights on this, then we're happy to hear them now. Otherwise, to contact us offline. So for open discussion, please, if you have any questions, comments, or answers to these questions, let us know.
Thank you, Georgios. I think we will have the Q&A session a bit later. So I suggest, in the interest of time, that we go to the presentation of the next report. I think we can go to the next slide. So Antonio.
Yeah, okay.
Yes.
Yeah,
Yes.
colleagues, please think about the questions, and then we can have an open discussion later. Yeah, thank you.
And also these questions will be valid for the second report as well.
Yeah, definitely. So I'm presenting the second report, guidance on integration of digital twins in data space. Go to the next slide. It's a joint undertaking. It's not only AIOTI. Actually, it started with standard ICT document in the working group, which I was chairing. And then there was a presentation of project in BDVA. And with HS Booster, we decided to go into that work. Go to the next slide. So you have the contributors. I don't want to get into the details, but I want to say that it's not only European. You have Claude Baudouin for the Digital Twin Consortium, so it's completely international. You have Jishan Li from China, Southern Power Grid, and Kim Yan from Cisco in Australia. Go to the next slide. So the idea is actually we're going to present the focus, which is integration of digital twin data space. We're going to present the context. So what are standardization needs? The architectural approach, allowing us to get standardization insight. And this document leverages three previous reports. One from Stand ICT, and you have the called landscape of digital twins. You have the URL. AIOTI produced in September 2022 a guidance of integration of IoT edge computing data space. The document is also available. And BDVA also presented a document, Data Sharing Space and Interoperability, which I actually authored, and you have the link. Go to the next slide. So the context is the following. We have data spaces, okay? And you have here a list of initiatives. EU Common European Data Space Strategic Initiative, the Simple, Cloud to Edge Federations, Gaia X. You have several projects. You have the DSSC, Support Action for overall data space support. And you have, for instance, the Internet, amongst others, by the way, which is focusing on energy data space, okay? And the last but not least, you have an international association, which is actually launched in Europe called IDSA, which is in charge of making sure that we get together. So we have also other things on digital twins. I get more later, IoT and edge computing. And I want to highlight a number of standards that are associated with it. So this report was produced by the working group standardization. Okay, so we were involved in all the listed standards here. So two that are published, the 3141 edition 2, published this year, IoT reference architecture. Edge computing, this one is quite old, 3 or 4 years old. Then I'm the editor of 3188, Digital Twin Reference Architecture. I'm also the editor of I'm not only contributing on 2141, Data Space Concept and Characteristic. This is a working draft, and it's led by Australia, okay? Then we have 3141. This one is led by China. I'm co-editor, Digital Twin Extractions and Transactional Data Products. And the last 3152, which is taking actually the title of our document, Guidance on the Connection of Data Space. And this is actually, I am acting as editor. Go to the next slide. Okay, so just to show a glimpse of the content of the document, it shows a little bit the situation of digital twin reference architecture when we publish it. So on the left, you have the document that has been published, and you see here twin entities, digital entity, target entity, and the environment. Okay. On the right is a slight update that is being updated in August. Okay, and you see in yellow things that are different. So you have something called synchronization, and you replace interaction, because actually synchronization is stronger than interaction. Okay. You can also see that in the digital entity environment, we also have observable elements. Okay, because what is the important property of this paradigm is we are actually observing elements out in the environment and in the system and trying to make sense out of it, out of modeling and things like that. Go to the next slide. Also, another aspect is actually the life cycle view. And you can see that below you have the target entity with its life cycle, and the digital twin itself has its own life cycle. And they are desynchronized, meaning that you can have simulation design while the other one is operating in the other way around. Okay, so this is quite important to understand in the elaboration of a digital twin system. Go to the next slide. So here is the functional view of the current standard, and you can see there are two dimensions. So on the let's say the y dimension, you have the life cycle, inception, design, deployment, and so forth. And the x dimension, you have the type of functions you have, like define, execute, monitor and measure, analyze, control, and optimize. Okay, go to the next slide. So one thing that is quite important is interoperability, because by using the digital twin paradigm, we have a simplification of better understanding of the interoperability needs. Okay, so in red you see inner interoperability, which is the interoperability between the twin, the virtual twin, and its reality. Okay, then you have the outer interoperability, which is actually the interoperability between the twinned entities or the digital twin system. Okay, and the rest of the world. Okay, and you have then the last but not least, very important, is the transversal interoperability. Some people say federated interoperability, where actually digital twins are discussing together to achieve a higher level goal. Okay, go to the next slide. So here is an example. Actually, it was provided by China, okay, where you have on the left. So on the left and right is the same thing, but I will show to you the difference. So let's consider the picture on the left, okay. So you have data that is produced in the environment. So you see the green stuff. Then it's treated, and then it is transmitted to the digital twin. That's the red stuff. Then it's treated, and then it is provided to the outside world, to the data space, okay, and this is the blue stuff. Okay, and you see a difference. You see on top you have data space, and it was including the data products or the results of all this data pipeline. Okay, and actually the standard on the right on data space has decided not to focus on the data, but only to focus on the policies. So that's why the data are not part of the data space. Okay, in the sense of 2151, and you have noticed that we use a single word without space, so data space is attached, and this is going to be much easier if you want to search for data space in documents, and this will be the data space that will be standardized in 2151. Okay, get to the next slide. So how do we deal with this? And this is a contribution from Arnie Baer on a number of documents. Is what you call a data pipeline architecture patterns. When we know this, we have different ways to create the data pipelines, and here you have a number of them. Okay, so and it will be one of the goals in standardization to publish them, to document them, and to leave actually the freedom to people to invent their own data pipeline according to their needs. Okay. Go to the next slide. So I'm going to show rather quickly a number of digital twin projects and how they were examined and analyzed in the document. Okay, so this is one is SPADE, Agriculture Digital Twin. Okay, it's a European project, and you'll see we have the URL when it is possible, and you can have a look to the project. Okay, so on the left you have the application, which shows that actually below you have the agriculture fields. On top you have the applications, so for instance the crops, the forest, the livestock, and then in between you have digital twins allowing allowing the applications to gather information, but they use IoTs, and actually they use drones. Okay, so this is the project, and what you see on the right is actually the interactions that take place between the different elements. So, and you have again the colors. So, green outer interoperability, red inner interoperability, and blue transversal interoperability. Okay, go to the next slide. So this is the second example with exactly the same thing about the connected vehicles. So on top, you will see applications such as mapping, parking, incident prevention, and the like. So you do exactly the same with maybe a difference that the IoT stuff are vehicles are moving. So the edge will be a mobile edge rather than a fixed edge. Okay. But once you have said that, on the right you have exactly the same thing. You have the outer interoperability, the inner interoperability, and the transversal interoperability. Okay. Get to the next slide. So if you don't mind, I'm going to show them rather quickly because you have the details in the document, but it's just also to acknowledge the contribution. I want to thank them to all those projects. Okay, so you have Herb Breast Smart City. So it's a smart city digital twin. Go to the next slide. You have Urban Age is another smart city, and you see again they made this effort to show the interoperability, but on the left you have the high-level architecture and the connector architecture is used because this is precisely the point. How to integrate the IoT to the data space, and you need connectors. Okay, next slide. So this use case is particularly interesting because it was provided by China, and they show how you will share data in substation and transformers. Okay, so again you have the IoT and edge infrastructure. You have the 3D model of the power grid, allowing you the digital twin to model what's going on. And on the right you have the interoperability approach. Okay, next slide. So this is a European project, a gift on the flexibility of energy in islands, I think. And you see on the left, you have the ecosystem that is being used, and on the right, digital twin that is doing actually the service of providing applications. Okay, go to the next slide. So Enershare is a data space project on energy, and they also implement a digital twin. So they have a high-level architecture, and on the right you have actually the data pipeline, how it is done from the electricity network up to the user interface, and with the digital twin simulation in the middle. Okay. Go to the next slide. So we got a few contributions, but not much detail. But we still want to mention them on from the Digital Twin Consortium. And this is a wind farm remote operation centers. And I had only a picture to show those. I just wanted to show it and acknowledge the contributions for the Digital Twin Consortium. So probably it's a US-based pilot. Okay, go to the next slide. The next slide is the same thing, but for manufacturing quality control via a remote operator. Okay, so again, I have a picture which I picked up from the website, and the URL you have it, and they provide more information on the purpose of the digital twin. And we need to work with them to have more information on the technical architecture of it so that we can go to standardization. Go to the next slide. So this is a project on circular smart manufacturing, and I think it's a European project. Yeah, circular twin. Okay, and it starts with IDTA asset administration shell specifications. It uses the Eclipse connector, and it combines digital twin and data space. And you have on the top left, right, let's say the approach for integrating digital twins and data space. Go to the next slide. So this one in particular interesting is a digital twin of the oceans, and it seems from the contribution we got that it's actually the union of two projects, Ocean Twin and Edito, and you can see here the vision of the architecture and how it has been implemented in a digital twin. Okay. Go to the next slide. Aqua Infra is a European project which actually dealing with smart aquaculture. And again, on the left, you have the high-level architecture. On the right, the digital twin that is implementing the capabilities. Go to the next slide. So out of this, it was very rich, and we haven't finished because there were in the pipe before publication about 7 or 8 projects that were still wanting to provide comments. So it might be that we have with Damir release 2 of the document pretty soon. Okay. But what I have to say is that we came up with 2 recommendations. We started with 3 recommendations of the previous report, which was stating that we need to agree on data space principles, to work on data space standards following an architectural standards, and to integrate IoT, edge, and digital twin concerns. Okay, so I have to say the 3 recommendations has been followed because R1 we have a standard 2141 that is being published, so we are working on it. Okay, and there are standards, and you can see that we have standards not only on the data space but on what is below and on the data pipeline. Okay, so when we have this, we have the full stack of layers that are needed from the IoT to the data space using digital twins. Okay, so the report is stating 2 recommendations. First, create a repository of architecture patterns to capture the different approaches to be connected to data space. Okay, we have quite a few, and we are going to do it first of all in AIOTI and promote them in SC41 in the next stage. Okay, the second is really important is interoperability is key. So there are a few projects in which actually IOTI is involved, like in STAR, okay? And we want to create international standards and to check cross-border data flows, for instance, between EU and other markets, for USA, China, Japan, okay? And I think I'm done. Let's go to the next slide. Yeah, so this is exactly the last slide is actually the goal was to promote the key result. And the question to the community, is this report useful for you guys? And are there, let's say, other initiatives that need to be included in subsequent release and things like that? Okay, so we are completely embracing everyone. Okay, so AIOTI has a tradition of inviting external experts outside even Europe to participate, and it's creating a lot of synergy, and we hope this will continue. Next slide. So this slide is actually the same as the one we showed in the previous, so we can get to the next stage. Yeah, see that question from the audience. Okay, so let me see if there are questions on the chat. Okay. So, Georgios, do you want to take some of them? Because there is a HLA relation to reference architecture on IoT, digital twin, maritime.
Yes.
Do you want? Yeah, Georgios.
Yeah,
Go ahead.
yes. So what I was also mentioned in the chat is, the release 6, but also previous releases. We are actually not covering all the types of IoT and or edge architectures to map them and to see how HLA could be used in those cases. So if there are topics that are very interesting for our members and also are useful for the industry, then this could be well seen as an input to as an answer to one of the questions that I had to work towards release 7 of the HLA. So I see that Ruti already provided some information about the computing continuum and edge and IoT, the COE architecture that could be, if we could use it in order to map the HLA to see the relation between HLA and this architecture. We have already one section in our report that provides, discusses the UC architecture. but the next step is to know how to map it or how to see the relations between this architecture and the HLA aspect. So
Okay.
I think that's a good point.
Yeah.
And regarding to what Asbjørn asked, so Asbjørn, if there are issues to discuss, we can discuss them and see how we can incorporate them in the release.
Yes, thank you.
Okay, so there is a second remark. So I'm going to take it this one. Okay, it's from Rute about the relationship alignment with EU CEI. So I guess EU CEI means EU Cloud Edge IoT. Okay, so of course there are lots of work being done in current projects, by the way, on the EU, the Cloud Edge IoT, in particular. There was a task force called architecture, so of course related to that, and the work they did was to come up with a taxonomy. Okay, the taxonomy was presented to ISO SC41 in June in Helsinki during the plenary. It was accepted, so a work item has been proposed called architecture considerations on IoT edge cloud. Okay, so and the relationship is the following: there will be patterns that will be provided out of the IoT edge cloud work. So maybe some of them even can compete, but it doesn't matter because those are options and they can be integrated in subsequent architecture, including in the implementation of a digital twin in the data pipeline. Okay, because the digital twin is where you have the data pipeline, but the data pipeline includes the edge. So we have to have patterns that mix both. Okay, and we are working separately, but at the end of the day, those patterns must be made available so that people can pick up what they want. In particular, if they like, say, one of the European projects is successful and one of the architecture is the one that is winning or maybe gaining traction. Okay, then we have to show that it can be integrated in the implementation architecture. Okay, that's the whole rule of the game currently. I have to say that we take advantage of the fact that there is a awareness being created in ISO on architecture, on how to do this in a flexible way so that we can accommodate whatever solutions that we have. Okay. Are there other questions? I have to check. Okay, I don't see other questions. Okay. What do let's see if let me check in the. Do we have questions first of all, just to make sure I'm not forgetting? Okay. So please raise your hand. Okay. Let's see. Let's see. Okay. There is a question from Matt Boyle. Okay. Let me see. Let me check 2 seconds. Okay, chat.
Recording a slide, but
Okay. Yeah, the slides will be made available, I'm pretty sure. And
Recording
Damir,
as well. Yeah.
the recording
we will
as
put
well.
both on our website most likely tomorrow.
Okay. Yeah. Okay.
and just I put here a URL for the IoT Edge and Cloud, activities that are, you can find the link there with all the information related to what Ruta mentioned. But yeah, so Ruta, we can also discuss, on how we can integrate this mapping and the relation of HLA with IoT Edge and Cloud aspect.
Okay, so in that case, I give you back the floor, Damir, for concluding.
Thank you very much, Antonio. Thank you all for.
Oh, okay. Sorry, Alex, you has a question regarding digital twin. Okay, so maybe we can leave one question. Take the floor, Alex.
Yes, thank you. Hi, how are you? Thanks for your presentation. It was very insightful. A question generally is like, how do you see the connection between digital twin and data spaces? It wasn't fully clear that is a digital twin accessing data through data spaces or also publishing data into data spaces or both?
So it's a decision of the implementer I believe that the digital twin is a nice paradigm. You can use others, okay, but it's probably the paradigm of choice to implement a data pipeline from the source to some place where you want to do exchange, okay. So which is the data space, okay, and in the spirit of 2151, what we call data space attached. It's only the policies and the rules to exchange, and then you can have shared space where you share data, or you can do this bilaterally. Okay, so in data space you have several ways. Sometimes you need intermediaries, sometimes you don't need. Everything will be open. The standards will not impose something. The market will decide. Okay, but again, to your question, so it's implementation decisions. And myself, my preference is the digital twin is below the connector. Okay.
Okay. So but yeah. Okay. Thank you. Yeah, that's fine.
Okay. Thank you. You can send me an email or you found a further exchange. Okay, no problem. Okay, Damir, back to you.
Thank you, Alex, for the question. Thank you, Antonio, for reply. Thank you also all the participants for your active participation. I hope it was useful, and as I already mentioned, we will make available both recording and the slides.
What do you mean, Damir? What do you mean? Svet had a question.
Sorry,
Svet?
who?
Oh, Svet is here.
Yes.
Okay, Svet is important. Okay.
Yeah,
Go
please
ahead,
go
Svet.
ahead.
Now I was trying first via the raising hand, because you said raise a hand. Okay, but I was looking at that. Now I just wanted for the architecture that is with the data spaces. You said that there were data layer, network layer. I'm looking at them now, and the application layer. But within a data space, we have two flows of data. So there is one of the metadata to signal to find the right data, etc. And then there is the user data that flows between the connectors, right? Again, it's not within the data space, but it's still. So in this picture, first, where is the one flow of data and the other flow of data? And then the other question is if the user, the data consumer, is using an external provider of kind of AI capacity, say somebody that is offering GPUs or AI algorithms that can be used, etc. So how would this external entity that is the data consumer is using in order to process the algorithm, to process the data, how it is going to be connected on this architecture?
Okay.
This is figure 33, I think, that I'm referring to.
Yeah, Antonio, can you answer this question?
Yeah, I think I can answer as follows: is this picture doesn't show all the details, and we will need to extend exactly to what you say. But definitely, we must show the separation between metadata and data, and so this is one thing. And on the second thing, when you have let's say other people in the other organization in the supply chain, okay, this is part of the rules of the data space. So actually, to my understanding, okay, in a given data space attached, okay, so you might have a policy where you allow for this according to certain rules, okay, and of course some of the rules imply obligations to follow. Maybe you can even get to sovereignty issues, but certainly meeting the legislation would be one of the important rules. Okay, and then according to the rules, the data space attached will decide whether you can be part of the club or not. Okay, so I think those are actually I would say concerns that were not so visible when we wrote the version 6 of the HLA. So in the next version, there are actually input to be provided. So thank you for that, Svet.
Okay, thanks.
Again, thank you all. Thank you, Antonio and Georgios, for the presentation, and all of you for participation and very good questions. I think we have quite some food for thought for the next releases, and I think it was very useful. So we will also circle back to some of you directly for your comments and for the further input when we will be working on the next release. So thanks again, and have all nice rest of the day. Thank you. Bye-bye.
Yeah.
Take care, everyone.